All right, so next section, section 6, is going to be all about rational expressions, which is anything with a fraction, basically. And we're still going to be using our factoring that we just did in the last section. So that's why we had to spend all that time kind of reviewing your factoring methods, because when you have rational expressions and they want you to simplify it, you might have to factor the numerator or the denominator or both in order to try to simplify. So a rational expression, like I said, is a fraction, but it's going to be created by using polynomials. So you'll have a polynomial on the top and you'll have one on the bottom. When we have a polynomial on the bottom, we will have to be aware of numbers that we can't have be put in for your x because it would cause issues in the denominator. Just a reminder, for any fraction, the denominator can never be equal to 0, no matter what. That's what causes it to become undefined. Because if you have a calculator and you try to divide by 0, your calculator won't do it. It'll give you an error message because it's impossible to divide by 0. So when we factor these things, we'll have to kind of keep that in mind too, of what is something that would maybe cause the bottom to become zeroed out, and then that would be an issue. And we'll have to just write those out as excluded values. So you probably did this before, again, last year in Algebra 2 when you guys did all your factoring and then we got into these rational expressions. We've done this before where you factored, you simplified, and you had to state those excluded values. So on an example like this first one, we've got 7x over x squared minus 5x minus 14. I really can't do anything with the numerator because it's just 7x. There's nothing really for me to factor there. But on the bottom, I can factor that because that looks like those trinomials that we just spent talking about in the last section. Now remember, this one is just x squared. So this allows us to factor this pretty quickly because there's like that shortcut that we can use because there's just a 1 in front of the x squared right now. So if you think about this to yourself, you're going to find two numbers that multiply to that negative 14 and add to negative 5. What numbers are going to do that?
Negative 7 and positive 2.
Good. So you can kind of see how they did that down here. They wrote x minus 7 and x plus 2 to get their factors. Okay, so then what we're doing first is trying to figure out what are our undefined values, like what are the numbers that we can't have in our denominator. So after you factor it and you have those individual terms now, just like when we were solving them in the last section, you were setting them equal to 0. So you're doing that, but what we're using now is not using that to find like our roots. We're using that to find the numbers that would cause problems. So when they set x minus 7 equal to 0 and they solve, they get x equals 7. And when you set x plus 2 equal to 0, they get x equals negative 2. Those two numbers would cause the denominator to come out to be a 0 if I plugged them into that polynomial, and that would cause it to become undefined. So if I were to write this out as like a factored answer, I'm going to take this here. On the top, I'm going to write 7x because I said I can't do anything with that. On the bottom, I'm going to write x minus 7 and x plus 2. And then right after it, I'm going to write out those numbers that x cannot be equal to. So you're going to write x and then can't be equal to, and we're going to write those two numbers that we found down here when we solved the bottom. So the negative 2 and the 7. So this is what your answers are going to look like today. We're not solving for like the values of x. We're just trying to simplify these rational expressions a little bit. The only time that you're solving something is when you're in the denominator and you're setting those things equal to 0 to try to figure out what would cause problems. So let's do another one like this. If you go right underneath it there. Can we do anything with this numerator? Can you do anything with the 13x? No. Let's factor the bottom. Again, they kept it pretty simple for us. What are two numbers that would multiply to 16, add to negative 10? And I would say too, if you're getting pretty quick with your factoring, especially on ones like that, you don't need to write out all that T-chart stuff. If you just know what your numbers are, you can go straight to your factored form. So over here, I'm going to write 13x And then I would write x minus 8 and x minus 2 on the bottom. But what values can x not be equal to? Good, 8 and 2, because you just set those two bottom pieces equal to 0. So if you needed to do that, especially if they were more complex pieces when you were factoring, you'd set these both equal to 0, you'd solve, you get 8 and 2.
Do we have to like write the full? Do you have to write the stuff on the left?
Yeah, you do. Because sometimes not all answers are going to look like that. You might start factoring and then you might actually be able to start crossing things off. And so it's going to simplify the expression. But yeah, we do want to see that simplified form. Okay, so if you guys turn it over here, we're going to kind of get into those cases I was just mentioning that sometimes you're going to be able to factor and then also be able to simplify. So if ever you factor and there's a term or like a quantity in the numerator that's the exact same as the one in the denominator, you can just cancel them off because remember, anything divided by itself is 1. So they would just eliminate from the problem basically. But when you do that, you still want to make sure that you consider all possible answers in the denominator that could be issues. So what I would recommend that you do is you're going to want to factor your numerator and your denominator like we've been doing. Then what I would do before you try to start crossing stuff off, look at your denominator and figure out what are the issues that cause problems. And then write out those numbers, like which numbers are going to cause my expression to become undefined. Then you can start crossing things off. If you cross things off right away, sometimes what I see students do is they forget about maybe the term that they crossed off. And then they forget an excluded value that needed to be expressed. Okay, so this first example, I've got it kind of worked out here, so I'm going to talk through it here. But we've got 4x squared minus 23x minus 35 on the top, and then on the bottom, x squared minus 5x minus 14. Okay, we talked about how to factor both of these things in the last section, section 5. Now, the bottom one is like what we had just been factoring. It's pretty cut and dry, like you just do your shortcut and you're good to go. And that's what's showing up down here. So I'm just going to talk about this really quick. The two numbers that multiply to negative 14 and add to negative 5 were positive 2 and negative 7. So they wrote that out here, and then you set them equal to 0. Now that's going to be in your denominator. So you can also see down below, they wrote out these factored pieces down here, x minus 7 and x plus 2. Now the numerator, unfortunately, we can't go that quickly with it because there's not a 1 in front of that x squared. So this is using that grouping method that we talked about. So they're showing you that they took the a times c over here. 4 times the 35 is 140. And then you're trying to figure out numbers that would add to that negative 23. So if you were setting this up yourself, you would say I need numbers that multiply to 140, and I need numbers that add to that negative 23 in the middle. Okay, and those numbers at work, they're giving them to us here, it's 5 and 28. So it'd be negative, oh, hang on a second. Oh, that would be a negative 40. They did not write that. Okay, see how that's a negative 35? So this should be negative 140 here. That'll change those numbers a little bit. So I want to add these together and get a negative 23. That means that the 28 needs to be negative. So just squeeze that in there. Okay, so negative 28 times 5 is going to give me that negative 140. Negative 28 plus 5 is how we get that negative 23. So if we think back to what we did in that last section, when you have those numbers, you can't just go straight to your parentheses, but you have to do that rewriting process. So that's what they're showing you over here, where it's got the 4x squared plus 5x minus 28x. That's taking these numbers from that chart and putting them into the problem. And then we do our grouping. And so they show you that remainder over here. They group the first two, they group the second two terms, and they start taking out what they have in common. So in that first set, they could only take out an x, and in the second set, they could take out a negative 7, and then this is your final factored of the top. So kind of is what we had been doing, but they already wrote it out for us, so we can kind of just follow along. They will eventually make us start actually factoring ourselves. Okay, so now that we factored the top and the bottom, we can see our answer down here. 4x plus 5 is on the top with the x minus 7, and then on the bottom is x minus 7 and x plus 2. What is in both the numerator and the denominator? X minus 7. So all we have to do is just cross them off, and we're left with this 4x plus 5 over an x plus 2. But what I would also include is those undefined values. Now they write that out over here, but if we were to add it on like what we saw on the other page, it would be x cannot be equal to, up here, that negative 2 and 7 that we found earlier. So anytime you have quantities that look exactly the same, everything about them has to match, same letter, same sign, same number, then you can just cross them off. But then make sure you include your undefined values as well, and make sure you think about that before you cross off things, because if you forget, you might miss one of those undefined values. Okay, so like I said, that one kind of was already worked out for us, but let's do one where we have to do everything. All right, so let's take a look at this one. That top one, really similar to our bell ringer today, because it's two terms, there's a minus sign, so it's a difference of squares. How can we factor that top? Good, so the top becomes x plus 2 and x minus 2. Okay, that was an easy thing to factor. Now the bottom, not so much. We have to do our grouping. How do we start to factor the bottom here?
Multiply it to 24 and add up to
3 and, what'd you say? We multiply what? 3 and 8. Negative 8. Which is negative 24. So you always start by taking your A times your C. So I'm multiplying to a negative 24, and I'm adding to what? 2. Good. What's going to do that? Okay, we can't go straight to our parentheses yet. We have to do some rewriting. So I'm going to just draw an arrow here. I'm taking this, and I'm rewriting it. So remember, we keep the first term, and you keep the last term. In the middle are those numbers. It doesn't matter the order. Okay, if we group, what can we take out of the first set? What's left over? Good. From the second set, what are we taking out? Good. That way we're left with x plus 2. Okay. So up here, back onto what I was writing out for my simplified thing, what's going to go on the bottom here?
3x minus 4 and x plus 2.
Good. Okay. Before we simplify, let's think about values in the denominator that would be undefined. So if you think about setting these equal to 0, so the 3x minus 4 and the x plus 2, if you set those each equal to 0, what do you get for undefined values?
4 over 3
4 over 3
and negative 2.
and negative 2. Okay, so we'll have to make sure that we state those. Is there anything that we can simplify from my expression up here? The x plus 2. So I'm just going to cross those off. Okay, so my final answer is going to look like this. After all that work, we should be able to write x minus 2 over 3x minus 4. And then we want to put after that, x can't be equal to these two numbers down here, 4/3 and negative 2. Yeah.
Wouldn't it be a positive 2 since you're taking x minus 2 to 0? And then you would add it and then it would be positive 2? Because in the green you did x plus 2. It wouldn't be x minus 2.
I don't think so, because when I factored over here, because when I factored here, we took out a 3x, and we took out the negative here from both, so that does change it to positive. So that's where I'm getting my x plus 2 from. And then you set that quantity equal to 0. That's why I got negative 2.
Okay.
Questions on simplifying expressions like that? Okay, so we're going to continue to do that process. We're going to continue to factor, continue to simplify. They won't always have things that need like a lot of work to factor. Usually with these ones, we try to keep them so that they can be factored pretty quickly, because we're now at the point where like we want you to be able to factor, but we also want you to be able to reduce. I don't want you to have to spend a ton of time doing all of that factoring all the time. That doesn't mean that you'll never see a case like that, but usually we try to keep it so that you can factor it pretty quickly. So now we're going to switch a little bit here. Instead of just simplifying an expression, we're going to start performing operations. So we can add, divide, subtract, and multiply all of these kinds of expressions here. So we're going to talk about how to do that. We're going to start with multiplying and dividing because they are easier than adding and subtracting. So multiplying, you're going to, again, just factor everything. Factor your numerator, factor your denominator. If they ask for those undefined values, we'll have to make sure that we state those. They may not ask for undefined values on these ones. They might just want you to multiply and simplify the expression. So then, just like before, we should be able to cross anything off. But this time, if you have multiple expressions that you're multiplying, anywhere where you see something in the top and in the bottom that's the same, it's free game for you to cross it off. So they don't have to be in the same fraction anymore. They could be in totally separate fractions and you can still cross them off. Okay, so for this first one, they kind of started the first expression for us. So we just need to finish it off. They kept the x plus 3 on the top. They saw that difference of squares here on the bottom. That's what we just did on the other one. And it was x plus 2, x minus 2. How can we factor the other expression? Let's start with the top. What two numbers would multiply to a negative 6 and add to a negative 2?
Negative 3 and 2.
Good, so x minus 3x plus 2. What about the bottom? What multiplies to 9, adds to 6? 3 and 3. And I would write them out separately. I know when we were factoring, we would maybe write that as a quantity squared. But right now, if I can cross things off, I want to see every single term so that I can cross off maybe more than one thing. All right, what can we cross off? Okay, you can only cross off one at a time. So there's an x plus 3 on the top, there's 2 on the bottom. You can only get rid of one from the bottom. You can't get rid of all of them because there's not enough to do that. So you can only kind of cross off even numbers of things. Okay, so left on top would be x minus 3. What's left on the bottom? Good. They don't ask for it. They don't ask for the undefined expressions, but if you needed to state that, you'd have to look at all the pieces that are in the bottom right now. So you'd have to look at the x plus 2, x minus 2, x plus 3. You'd have to set all of those equal to 0 and state that. But I'm not going to worry about doing that at the moment. Just make sure on like a homework assignment or something, read the directions, and if it asks for the excluded values, then you have to state them. Okay? All right, why don't you guys go ahead and try that second one?
Yeah.
No, I would just keep it. Okay. Okay, how'd you guys factor your first fraction?
Like the x plus, like that squared. I just left it.
Yeah, I would leave the top for sure. There's nothing we can do with that because it doesn't fall into any of like our rules. You know, when I had two terms, we would look for like the difference of squares, or we talked about like the sum and difference of cubes, but that doesn't apply here. 3 is not a perfect square number, and there's not a minus sign. So there's really nothing we can do with that. What about the bottom though?
X minus 3 and x plus 3.
Good, because that one is a difference of squares. You can square root both terms. There's a minus sign, so it's good to go. How about the other side? Let's start with the top.
X plus 3 and then x plus 5.
Good. And the bottom?
X plus 4 and then x plus 5.
Very good. Okay. What'd you guys all cross off?
The x plus 5. And then the x plus 3.
All right. And so we're left with x squared plus 3 on the top. And on the bottom, x minus 3 and x plus 1. If you have the bottom terms flipped, it doesn't matter. Okay, because you might have factored that a little bit differently than mine, or you might be writing them differently. That's fine. They just all need to be there. Okay? Questions on that one with the multiplying? So if you guys go over to the next page, dividing is next. And it's really not all that different from multiplying. We just have to make sure we do one little thing. Anytime you guys divide fractions, you've probably always just been told don't actually divide a fraction by a fraction because it gets really messy if we try to do that. It looks crazy when you try to set it up. So we always talk about multiplying by the reciprocal. You're going to do the same thing here. So I would still, you're still going to factor, but I would maybe think about flipping that second fraction upside down first before you start factoring it. So that's what it says right here. It says invert the divisor and multiply. So I want you to take this fraction, I want you to flip it upside down. I'm not going to do anything to the first one. So right now all I'm going to do, guys, is just rewrite this problem. And when you flip that over, it becomes a multiplication problem now. Okay, now let's try to start factoring. So let's start with the top. How should we factor the top?
-1, -2.
Yeah, so you're thinking numbers that multiply to 1 add to -2. Well, the only numbers that multiply to 1 are 1. But since I want to add to a -2, they both need to be -1. So x minus 1, x minus 1. And again, I'm going to leave those out separately. Can we do anything with the bottom? We can take an x out. So instead of having like one of those things where we get two quantities in parentheses, we're talking about GCF now. They both have at least one x. And if I take one x out, what does that leave me with?
X squared.
Good, x squared plus 1. Okay, on the other side, on the top, if we take a 3 out, what are we left with?
X squared plus 3 or 1.
Good. And the bottom?
X plus 2 and x minus 1.
Good. Okay, what can we get rid of?
X squared plus 9. And x minus 1.
So what's left on top?
3 x minus 1. And x plus 2.
Good. And you don't have to multiply that 3 in or the x in. You can just leave it here in this factored form. You can distribute it in if you want to. It doesn't hurt anything, but I would just leave it right here for right now, just because eventually when you start adding and subtracting, you won't want to have those pieces put back together like that. All right. Any questions so far on simplifying those expressions, multiplying, dividing? Okay, I'm gonna call it for today just because we're getting into adding and subtracting next, and I'm gonna save that for the next class.